explain to you using another example before we dive into 16. So let's pretend we are provided an angle that you are used to, like 2 pi over 3. Well, we all know where 2 pi over 3 is. It's right here. And we know that 2 pi over 3 is equivalent to 4 pi over 6. We just put it in reduced form. And so when they're saying which of the following is a coterminal angle, it means you can go around as many times or revolutions as you want, but when you land here, so I'll give you some coterminal angles to 2 pi over 3. So here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 pi over 6, which would reduce, dividing by 2 and dividing by 2, to 8 pi over 3. That's a coterminal angle. Or I could do it again, a second one. So here is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 28 pi over 6 reduces to 14 pi over 3. Well, is there an easier way to write this? There is. We could take 2 pi over 3, and we can add 2 pi, so another revolution, and this k value tells you that k could be any integer, so it can be positive or it could be negative. So we could start here, and if we went with a positive 2 pi, we'd end up here. With a negative pi, we still end up here. We can go either way if we do a full revolutions, and we can do as many revolutions as we like. Okay, let's apply that up here. Let me take my paper and let's flip it around. So 2 pi over 7 isn't one of the places that we've memorized, but we do know that if we take it and we add to it 2 pi, now k can be whatever we want it to be. It could be 1, 2, negative 1, negative 2. It could be any integer. We want to find which ones match this. So for instance, if we made k equal to 1, we'd have 2 pi over 7 plus, well, 1 times 2 would be plus 2 pi. Now we need to come up with a common denominator. Right now 1 is on the bottom, so I'm going to be lazy. I'm going to take this times 7 and times 7. Why did I do that? Because now I have a common denominator of 7. 2 pi over 7 plus 7 times 2 is 14. 14 pi over 7. When we add together, keeping the denominators the same, we end up with 16 pi over 7. Is 16 pi over 7 there? No, 16 pi over 7 is not there. But notice I have smaller versions. So from here, my next revolution one time around would be 16 pi over 7. And I can see that these would be in between there. We haven't even gone an entire revolution. What if we made this a negative 1? So let's take 2 pi over 7. Let me move this down, and let's do, well, negative 1 times 2 would be negative 2 pi. The exact same thing. I want a common denominator to be the same. So I take it times 7 times 7. You could use the McFarland method, the butterfly method. You get the same answer. 2 pi over 7. 2 times 7 is 14 pi over 7. 2 pi minus 14 pi is negative 12 pi over 7. So because it's negative, as I demonstrated on that previous one where we used 2 pi over 3, at this point, if we add a 2 pi version that's positive, we're going to go counterclockwise or clockwise, and if we'd make it a negative, we'd go opposite of that, or actually clockwise would be if k is negative, and counterclockwise would be if k was positive. And here we end up with negative 12 pi over 7 when k was negative 1. That is an option. Correct answer is